So now that we know what it means for a function to be one-to-one, by looking at it, by understanding that, that for each y in the range only has one path that takes us there, we can talk a little bit more about notation and about the way these inverses work. So back to this boring function that has 1 point in the domain and 1 point in the range, and a goes to b, so f of a is b. So ab is a point on the graph. All of those say the same exact thing. If I want to talk about the inverse of this function, then it's going to go in reverse. It's going to start at b, and it's going to take me back to a. Now, the notation that we use when we're talking about the inverse of a function is we say f inverse of x. Or here in this case, f inverse of b is equal to a. Now, the important thing to keep in mind is that when we are talking about f inverse of x, okay, this little guy up here, this -1, is not an exponent. Okay, that's part of the notation. Just like f touching x in parentheses does not mean that they're multiplied together, f inverse of x does not mean the same thing as 1 over f of x. It's not an exponent that drops it to the bottom. Okay? So I'm going to scribble through that so you don't even think about that again. But those two things don't mean the same. Now, notice what's going on here. When we say f inverse of b is equal to a, that's the same thing as saying that BA is a point on the graph of the inverse. Also, since b is the number that went into the inverse function, that means the blob over here on the right is the domain of that inverse function. Okay, b is the number that went into it. Okay, and since a is the number that came out, the set of numbers that comes out of a function is the range. Some relationships that we have between a function and an inverse are these things that we have up here in black and blue. Okay, the domain of 1, so the domain of f is the same exact set of numbers as the range of f inverse. Okay, the other piece is true as well. The numbers that come out of f are the numbers that go into the inverse. The domain of 1 is the range of the other. Also, if AB is a point on the graph of f of x, then BA is a point on the graph of the inverse. And that will lead us to, we're going to look at some graphs of some functions here, some one-to-one functions that have inverses, and see what that looks like overall. If I can find a clean page. So let's stick with something that is, I'm going to use the word simple to us, hopefully, and that would be a straight line. Okay, maybe I have the line that goes through the point 0, -2, and it goes through the point 1, 0, and it goes through the point 2, 2, and it goes through the point 3, 4. All right, so if I look at that line right there on the board, it is a one-to-one function. Hopefully you would all agree with that. If I draw horizontal lines through it, each one only intersects it at one point. So that means I know that it has an inverse. We'll call this f of x. Now, because I know about lines, if I wanted to actually write that equation of the line, I could. Excuse me. Sorry about that. But I'm not going to worry about that today. Okay, but since this function is one-to-one, if I want to sketch a graph of its inverse, okay, if the point 3, 4 is on the graph of f, then I know 4, 3 is on the graph of the inverse. from our diagram that we just had. We said AB is on one, BA is on the other. We don't have to do anything fancy. We don't change any signs. We don't flip anything any which way other than x becomes y and y becomes x. Okay, so 2, 2 stays 2, 2. 1, 0 becomes 0, 1. And 0, negative 2 becomes negative 2, 0. And I missed there, but pretend that that goes through my points. When you sketch a graph of a function and its inverse, it will have a symmetry always. Okay, not just special with these two straight lines. Okay, remember symmetry we talked about in chapter 2. A symmetry means a line that I can fold the paper on where the sides will match up with each other. Now it's not x-axis or y-axis symmetry. It's not anything like that. Okay. Notice if I fold my paper right here, and this is along the line y equals x. If I fold it on the diagonal, the green graph and the blue graph line up with each other. And that will always happen. Look in your textbook, look at examples. It has several, and I'm not going to take time to draw lots and lots on the board today. Okay, but if you look at two functions, and you can draw that black line on there, that dotted line I have, okay, if the blue and the green line up with each other, that's what two graphs of inverse functions will look like. So then the next thing I say is, well, maybe I have a function, f of x equals 2x plus 3. And that's a straight line, and all straight lines are going to be one-to-one, except for horizontal lines, okay, or vertical lines that aren't functions to begin with. Okay, so since the slope is 2, I know it's a one-to-one function, so it's going to have an inverse. Maybe I want to look at g of x equals 1/2 x minus 3. Okay. And my question to you is, are these two functions inverses? Right. So if we're looking back at this relationship here, and we're looking at visually that relationship there that we said, and I want to know whether or not two functions are inverses of each other. We have to know one other thing. These are usually the things that I scatter around on the whiteboard so I can keep writing on the smartboard. But I'm going to stop whining now about only having this. If I have a function and I have its inverse, okay, if I look at f of f inverse of x and take the composition of those two functions in either order, it doesn't matter which one I plug into what. Okay, either way, in the end, okay, all that's going to come out is the plain old x. This will be true for all x's. I'm going to write x's in the domain of the inner function. So if I want to check, if I have two functions given to me, and the question is, are those two functions inverses of each other? Then at my desk, I can find the composition of those two functions and see what happens. If I plug one function into the other and all that comes out of that is a plain old x, then I know that, yes, these functions are inverses. If I get anything other than x, if I get x plus 1, if I get negative x, if I get 1 over x, then I stop and say, no, those guys are not inverses of each other. So if I'm asked to find f of g of x, that means I am plugging g into f. Okay, so if I pick up, sorry, minus sign. If I pick up g and I plug it into f, every place there's an x, I do the arithmetic and clean things up. Okay, what came out of that is something other than plain old x. X minus 3, not okay. X plus 4, not okay. 1/2 x plus 9, not okay. Okay, so since this is not equal to plain old regular boring old x, I come back up here to my question and I say, No, these guys are not inverses. Now it doesn't matter which function I plug into where. So if instead I wanted to plug f into g, I could have gone there. Okay, maybe your neighbor plugged g into f. I want to plug f into g. So instead of x, I'm going to plug in 2x plus 3. When I do the arithmetic, x plus 3 halves minus 3 is x minus 3 halves, which is also not equal to x. I only had to do one thing or the other. You do not have to plug it in both ways. Okay, notice that what I got when I plugged it in, f into g versus g into f, I got something different. Okay, and it doesn't matter what it looks like, those will almost never be the same thing unless you get x out of both of them. Okay, so pick one, your favorite one, plug one into the other. If you get plain old x, okay, you're in good shape. If you get something else, then you say no, not inverses. Also, fair warning, the examples in the textbook, not just straight lines, there's other things. All of those other things are things that we did back in chapter R. There is one complex fraction that will be assigned because that will show up on your final exam. And we need practice with all of those things as we're going forward. Okay, my video is getting too long, so I'm going to stop it here and I'm going to pick up. There's more to be said about this, but I'm going to pick it up here in the next video.